Okay, so for this week, we're going to talk a little bit about feature engineering and imputation. And I'm going to try to keep this video a little shorter than the previous ones have been and really just try to provide some context for the slides that you can go in and look at separately as well in a little more detail. And then I'll also call out a couple places where we'll be talking in class about some of the pieces of feature engineering and imputation and how they might apply to your projects. So today cover feature engineering, a little bit about bias and feature development, which we'll really dig more into in lecture this week, and then a little bit about dealing with missing data and kind of methods for imputation. Just to get started, why do we care? And kind of the top reason why we care is really because feature generation is probably perhaps the most important part of the machine learning process. You can use the most complex modeling method in the world, and if you don't have very good features as input, if you're not really representing the data to the model in a very good way, you might get terrible results. Whereas on the other side, right, if you have been very thoughtful about your features, very thoughtful about what you're putting into the model, sometimes that allows you to use less complex models because you've kind of encoded the complexity in the features, which might be faster to run, easier to maintain, easier to understand, especially for policymakers. And two, you might just get better results in general, kind of regardless of the complexity of the model. I like to tend to think about, feature engineering really as taking domain knowledge and encoding it in ways that your model can actually make use of. So it's kind of hints and rules of thumb that you're providing for the model to make its job easier and to make it more effective at detecting the thing that you're trying to predict. That I think as you're starting to think about what features you want to build for the modeling that you're going to be doing for the class in your project, we want to make sure to highlight a couple of practical pointers. And probably the big one here is, what did you know and when did you know it? Leakage will be kind of an ongoing theme that we'll talk about a lot through class, and I think next week we'll also be talking a lot about model evaluation and dealing with kind of time and the temporal structure of the data there. And that's very important here as well. When you're creating a given feature for a given cohort in your data, you can really only use information that was available before the date that is being used to train that model. And that sounds obvious and straightforward, and kind of in general it sort of is, but in practice it can be a bit more challenging. Project after project, we almost always run into leakage in some of our early iterations, and often that's runs into things like the structure of the database, especially many kind of administrative databases. We'll do things like overwrite data as new information comes in. Maybe you have a status field, and that status is just getting updated with time without any record of what it used to be, or the fact that it was overwritten, even if there's some creation date associated with a given row. We've seen that sort of thing a lot. It's an important thing to watch out for in your own projects, because then if you just sort of blindly use that status column as an input for one of your features in your models, it may be picking up information that it shouldn't have access to. This is also why we'll talk a lot about the difference between kind of validating on past data and sort of the more gold standard for evaluating model performance is to make predictions about really truly future unseen data, and of course we'll be getting into a lot of that going forward as well. The other thing I'd say here is really draw on, kind of domain expertise and expert knowledge. That's again something that we do constantly throughout the projects that we work on. I remember an example working with the city of San Jose, looking at properties that are likely to have health and safety violations at kind of apartment buildings. And in our sort of initial round of feature engineering, we had some access to kind of building permit data, but hadn't really looked at that. We're looking more at, histories of violations and things like that. And some of the inspectors that we talked to who actually go out and do these safety inspections said, oh no, if a property, hasn't had any building permits in, 10 years or a long time, that probably means that they aren't doing the maintenance that they should be doing. They're not keeping things up to date. So there's a lot more likely to be problems at those properties. And so getting that sort of expertise and pulling it in will really help kind of guide your feature development. So, those are a couple of things to keep in mind as you're starting to dig into your projects and of course in the future generally. The other, real piece of advice is like everything in the machine learning pipeline process, this is, very, very much an iterative process as well. Start simple. Look for just the handful of features that you think will be particularly important based on what you know about the domain and the problem, and maybe even some kind of initial data exploration that you're doing right now. Build those out first. See how they work. Those will give you ideas for new features as well. You'll implement those, see how they work, decide whether you want to keep or discard them, and kind of keep iterating, building out more and more complexity and information as you go. Bias in feature development is a really important area to be thinking about as you're getting into your projects as well. And I won't spend a lot of time on it here. There's some kind of notes and leading questions in the slides for you to think about. And then it's something that we're going to come back to in the live discussion on Tuesday, where we can really get into both, where bias might be creeping in and how that might affect your projects. But, in general, you kind of want to be thinking about how might this feature vary across groups? How might its predictiveness vary across groups? How might data quality vary across groups? As well as things like if you're making inferences, so if you're building, say, age or gender kind of inferences based on people's first and last names, your ways of doing that might be more or less reasonable or correct across different groups and different types of people. And thinking about how you're binning data, creating categories, thinking about how the data is collected. So be thinking about all those things in the context of your project, and we'll talk about this in a lot more detail on Tuesday. In terms of kind of the sort of practical, pieces of feature generation, we won't spend a ton of time on this in the video here. I think we kind of imagine that you all have some familiarity with creating categoricals or cutting different bins and discretizing features and things like that. We'll talk a little bit about kind of missing values, particularly in the second half of this video. And see the slides. There's a couple of pointers and things to be thinking about in there as well. I do want to spend 1 or 2 minutes talking a little bit about kind of aggregations and relative features that maybe you haven't seen as much of in previous classes. And I think in a lot of, especially for people who've kind of taken more machine learning in school and maybe not done as much in application and out in kind of real world jobs, right? Often in a class, you're kind of given a data set and the columns sort of are the features, and you just kind of implement some model and build on top of that, which can make your life a lot easier if the focus is on kind of learning how to implement a given model or a given algorithm. but of course, with the real data that you're dealing with these projects, right, you have, columns or attributes or variables, however you want to call them in the database. But the features are kind of what you construct out of those. And in particular, as you're thinking about the really temporal nature of the data and often the spatial nature of the data, um, thinking about how you're going to aggregate some of that information and turn it into information that the model can use is really important. Just as, sort of uh, one kind of example, I think we've talked a little bit about before, where we were looking at predicting individuals who were likely to come back into jail with a misdemeanor offense, for a county that was trying to help reach out to those people proactively with mental health resources, to try to kind of break that cycle. There, we were thinking a lot about sort of temporal features relative to that person's history. How long has it been since the last time that they were booked into jail or had some mental health need that we can see in the data? Um, how long is kind of the typical spacing in between these interactions? How how many times have they been booked into jail in the last, say, 6 months, in the last year, in the last 5 years, in the last 10 years, or, through all the time that we have for them in the data. So, where you're kind of dealing with individual entities, you'll want to be thinking a lot about how do I kind of take this rich history of behavioral information that I have about them, and this is going to be true, I think, really for all of the projects that you're working on, and how do I aggregate that into different time cuts that the model can pick up on and actually make use of relative to whatever point in time I'm modeling for. But the similar is very much true for space or, you know, often for other kind of aggregates. One of the projects that we actually used for class last year was looking at a organization called Donors Choose that helps teachers and schools do some kind of crowdsourced fundraising for different projects that they want to do. And there, we were trying to look at projects that were likely to not be not meet their kind of funding goals. And to do that, some of the historical features that were particularly useful there weren't about this particular project, because we were predicting as of the time that the project started uh, or was posted on the website, but were aggregations of other kind of similar projects. So what about, other projects that were asking for the same resources, other projects in the school district, or, different levels of aggregation, start with maybe other projects the teacher posted, move out to at the same school, in the same school district, in the same county. And then you can let the model kind of figure out how important are these different levels of aggregation relative to each other. And that can be really useful where you have kind of different levels of sort of sparsity, right? Maybe a given teacher hasn't posted many projects, but a lot of projects have been posted from the same school. And so for those projects, you'll pick up more information from the school level, but for other projects, maybe it's even sparse at that level and you have to zoom out. And so the model can kind of help figure that out as well. And then kind of, similarly, right, uh, thinking about features that calculate kind of, is this above the norm or, above some percentile, can be really powerful as well in sort of giving the model kind of a hint about, right, how extreme this value is relative to others. So thinking about both of those types of features will probably prove pretty helpful as you're getting into your modeling. This is kind of one aside that we'll come back to in class as well. For a lot of different methods, scaling your data to have sort of similar ranges across different features can be very helpful and make the method work better. in terms of kind of figuring out how to treat one feature relative to others. And you can think about, scaling this to 0, 1, or kind of -1 to 1. So long as they all kind of have the same range, you could, standardize in kind of more the, mean and variance sort of sense. Anything like this can be a reasonable approach to scaling for different types of methods, and different methods will sort of need scaling more than others. So one thing that we'll kind of hit on when we chat in class, and maybe to think about before we get there, is right for these different types of methods, where is scaling important, where is it less critical, or is it critical everywhere? Kind of skip through a little bit more about transformations that you can check out in the slides as well. I think most folks are probably familiar with building kind of interactions of features, and especially when your kind of base model is a linear model, still letting you kind of pick up on some nonlinear relationships. And again, this is kind of one of those ways where, by building more complex features, you can get away with less complex sort of underlying models. So, again, we'll kind of come back to this in class, right? Different types of models may benefit more from different types of features. And so it's helpful as you're thinking about both the features that you want to build and what might be predictive of the outcomes that you're interested in, but also the modeling methods that you want to try applying to the problem. Thinking a little bit about, well, if I'm using linear models in my kind of search grid, they might benefit from these sorts of features. Nonlinear models might benefit from other kinds of features. So that's something else we'll talk a little bit about on Tuesday. So switching gears slightly, and talking a little bit about kind of missing values and imputation. There again, as with the features, be some more details in the slides. But I'll kind of go, at a high level here, as well as speak a little bit to some kind of, best practices that might be useful in the work that you're doing right now as well. So, here we're kind of talking about imputation and trying to deal with missingness in your data, but missingness in the data might be, just completely at random. Might be, not random at all. And you might want to handle those types of missingness differently. Sometimes missingness might be meaningful in its own right. And sometimes it might just be that something wasn't measured. So, we kind of always say, right, like, even if you're going to fill in the missing data, and most methods will need some value in there. One, you should be doing that thoughtfully, but two, it's generally a good practice, if there was missingness, to include a dummy binary feature in your feature set as well that indicates whether a value was imputed. And you might even think about, right, if you're doing kind of different levels or layers of imputation, that maybe you could include different dummies for, oh, this was imputed based on information in the census block, or this was imputed based on information at the county level because I didn't have information at the census block. So you kind of want to let the model know how you're handling the data, and then it can figure out how important or meaningful the fact that these two entities both have a value of 4 for a given feature, but one of them actually had a measured value of 4. One of them you filled in a value of 4 because it was the mean across the training set, and it can figure out if it should treat those things differently or not. So I think many of you probably have some experience with different methods out there. Definitely refer you to the slides for more details on each of these points. You can, most simply think about imputing kind of central tendency, whether that's like mean, median, maybe mode if it's categorical. You can think about doing some sort of regression, using, kind of more flexible things, k-nearest neighbor, doing multiple imputation, which kind of provides a little bit more of a sense of the variance, or, using models that handle the missingness more out of the box, like XGBoost. But then, of course, if you have other models in your grid, that don't handle the messiness, you'll still need to do some imputation for making use of random forests or logistic regressions. I think a big piece of advice here, as with the kind of feature generation, is, again, think in terms of simple terms first. Start with something that's very easy, and then kind of iterate on that and evaluate different options against one another. So some kind of general tips and tricks, especially for your current projects and and kind of going forward. The first big one is, right, like in many methods, the kind of default behavior is, oh, there's missingness here, well, I'm just gonna throw out often that row, sometimes that column. But this is almost always not the thing that you want to be doing. If there's a really very good reason for it, if 99% of the column's missing, and and you just can't infer anything from the rest, maybe maybe it makes sense to say, well, I don't really have access to that data for this modeling project. But by and large, there's I can't think of a practical time where, especially on a row level, we were dropping rows because of missingness. I think we have talked a little bit in the schools context about the challenges of figuring out where there's missing labels, how to treat those. But even there, certainly just out of the box, dropping those rows is probably not what you want to do, but you want to consider a couple of different ways of handling them. And then I think, as I was just mentioning before, the missingness itself can be a useful predictor and meaningful. So always make sure that you create a flag to tell the model what you're doing, and let it know how you're handling the data. This can often say something about maybe there was a sensitive field that some people just didn't want to fill out, or people didn't want to report their income or something like that because they thought that was personal information. So it might be providing you kind of an indication of something about the behavior, if you kind of know something about why the data is missing, and that can provide other information that might be useful for the prediction problem that you have at hand. Which I guess kind of leads into the next bullet point here, that data can be missing for many different reasons, and might need to be handled differently in those different cases. In kind of the one extreme, if you're thinking again about that project where you're looking at predicting recidivism for mental health intervention, if somebody had no record in the jail booking table, that's probably not missingness in the sense that we need to impute something there. It might just be a true zero. So sometimes missing is actually can be filled directly without thinking about it as imputation in kind of the traditional sense. Other times data might be missing in some tables where it's appropriate to just do mean imputation, and in other places where you actually want to do some sort of more complicated regression or something like that, that might relate to how predictive the feature is for your problem, or how much complexity, or how important it is to kind of get the feature uh, imputed with a little bit more accuracy, or might relate to why the information is missing in the first place. Is it at random? Do you think there's that it's not at random and missing more for certain groups than others? So I think the pointer here is really kind of be careful about it, and be thoughtful about what you're doing when you're imputing different values. And then, as we mentioned with feature engineering itself, only use the past for imputation. So, impute values for your training set from the training set, and don't use the test set. And this is again, something when you kind of put it down on paper, kind of seems obvious, but is easy to miss if you just ingest your data from the partner, pull it into the database, see where there's missingness across the entire data set, and just impute kind of at that ETL step. And then go and build your modeling and validation sets after that. You might kind of do it without realizing that, oh, but I just used the entire data set for imputation, and if things are changing over time, I might have kind of pulled some temporal information in that I shouldn't have. So usually we recommend there, as you're thinking about building out the different steps of your machine learning pipeline that we talked about last week, to really kind of figure out your training and test validation splits, and then do imputation as you're kind of doing feature building and feature construction downstream of both ingestion, ETL, and figuring out what the temporal splits are. So the last bit, we've mentioned a couple discussion questions along the way, and one that we'll probably spend a bit more time on Tuesday is thinking about different ways that bias might be introduced, both kind of as you're thinking about future development and handling missing data in your particular projects. So give that a little bit of thought, and on Tuesday we'll chat about these things as well together as a group. Yeah, and then just the only other reminders, again, there's more details in the slides themselves, so it's worth pulling those up and giving a quick look through those before class as well.